Chapter 15, Sample Problem Number 12. A liquid flows along a pipe through a junction as shown. The pressure and fluid speed on the left side of the junction are given, as well as the speed on the right side of the junction. Consider the change in pressure between the left and right of the junction. Check the appropriate box and explain your reasoning below. So, as a reminder, we're being asked to talk about the change in pressure. And we're going to go through and use Bernoulli's equation, which says that essentially it's an energy conservation equation. The pressure plus 1/2 rho times the velocity squared. So something essentially is the internal spring-like pressure of the spring-like energy of the fluid plus its kinetic energy should stay the same. So pressure 2 plus 1/2 rho velocity 2 squared. It's the same liquid. Liquids are generally incompressible, meaning their densities won't change from place to place, so we'll be able to treat that as just a constant between the two. And what we're actually looking for is delta P, the difference between P2 and P1. And if we look up here, we have P2 minus P1. We would bring P1 over that way, and we'd bring this over the other way. And we have 1/2 rho times V1 squared minus V2 squared. And we just want to rank these things, so we're just looking for the rank of those squares. So, and we want the change in pressure, so the actual left pressure is irrelevant, because we're not going to say what is the absolute pressure at the end, but only how much it's changed by. So if we just square everybody, we would have 25 squared and 100 squared, and so we end up with minus 75 for whatever that is. And here we have 125, so that's plus 75. And here we have 125, which is also plus 75. And here we have 81 minus 1, which is plus 80, and 81 minus 1, which is plus 80. So we see that our ranking is D is the same as E, which is greater than B, which is the same as C, which are greater than A, because any positive number is greater than any negative number. So there we go.